students, I have discussed about relations, types of relations, definitions of relations, domain and range of relations, and problem based on different types of relations. Today I will discuss some more problems, and further I will discuss equivalence class. What do you mean by equivalence class? First of all, I will take a problem like as let R be relation defined on the set of natural numbers, that is n, as follows. R is equal to set of such order pair AB such that A belongs to N, B also belongs to set of natural numbers, and 2A plus B is equal to 41. This is the set. Find the domain and range of the relation R. Also verify whether R is reflexive, symmetric, and transitive. Now we have choose A and B such that what will the value of A and what will the value of B. After putting the value of A and B, this must be satisfied. So set of natural numbers where A and B are belongs to set of natural numbers, therefore we start A is equal to 1. If A is equal to 1, 2 1 are 2 plus 39. 39 plus 2 is equal to 41. That means first order pair will be 1 and 39. 1 and 39. That means R is equal to, we establish relation R is equal to 139 is the order pair. Next order pair will be 2 and 37. If we put A is equal to 2 here, the 2 2 is 4, and then plus B, put B is equal to 37, we get 37 plus 4 is equal to 41. This is also satisfied, and this is the order pair will satisfy these conditions. And further, next order pair will be 3 and 35. We also observe that 3 2 is 6 plus 35. 6 plus 35, 41. Also order pair satisfy these conditions. 35. And similarly, we up to 19 and 3 order pair 20, 1. This is the last order pair. This is the relation established over these conditions. 2A plus B is equal to 41. If we put 20, A is equal to 20, so 20 2 is 40 plus 1, 41. 39 2 is 2, 38 plus 3, 3, 41. This is the order pair. This is the possible order pair here. Now we have to check this relation, whether it is reflexive, symmetric, and transitive. First of all, reflexivity. Reflexivity means element related to itself, but here we observe 1 related to 39, 2 related to 37, 3 related to 35, 19 related to 3. It is not possible. Here 1 1 does not belongs to R, 2 2 does not belongs to R, and therefore and so on. Hence it is not reflexive. Next, symmetry. We check symmetry. Here we observe that 139 order pair belongs to R, but 39, 1 order pair does not belongs to R. Hence it is not also symmetry. Transitivity. transitivity. Here we also observe that 11, 19 order pair belongs to set R, relation R. 19, 3 also belongs to R, but 11, 3 does not belongs to R. Hence, we conclude that R is not transitive. If we put 11 in this relation, 11 to the 22 plus 19 also 41, 19 to the 38 plus 3 41 also here, but 11 to the 21 plus 3 not applicable 41. Hence 11, 3 order pair does not belongs to R. It is not possible. Hence this condition is not fulfilled for the transitivity. Let us take one more problem, like as so that the relation R in a set A such that X belongs to set of integers, positive integers, such that 0 less than X less than equal to 12, given by R is equal to order pair AB such that mod A minus B is a multiple of 4. This is the relation established here on a set A. First of all, we form a set A. Solution A is equal to 0 also included, 0 1 2 3 and so on up to 12. This is the set A. Now we have to check reflexivity, symmetricity and transitivity. First of all, reflexivity. As we know that any number A belongs to A such that magnitude of A minus A 0, which is divisible by 4. Here multiple of 4 means this is divisible by 4. This is the meaning of this. Here A minus A, reflexivity A minus A is equal to 4. Suppose 2 minus 2 also 0 and 0 is divisible by 4. Hence this relation is reflexive. Hence it is reflexive. Next, symmetry. Suppose order pair AB belongs to R. This implies magnitude of A minus B is divisible by 4, and this implies magnitude of minus B minus B. We can write in other way, like as, since this is the modulus value always positive, therefore this is nothing but this is divisible by 4. This implies this is nothing but magnitude of B minus A is divisible by 4. Since we know that magnitude of minus 4 is equal to 4, and the magnitude of minus B minus A is equal to magnitude of b minus a. This is the next, and this is nothing but this means b comma order pair belongs to R. This imply a b order pair belongs to R. This imply b comma a order pair belongs to R, and this condition fulfilled for symmetricity. Hence it is symmetric. Next, transitivity. Let a comma b order pair belongs to R and b comma c order pair belongs to R. This means magnitude of a minus b is divisible by 4 and magnitude of b minus c is also divisible by 4, and this imply a minus b is divisible by 4 and b minus c is also divisible by 4, and therefore this imply a minus b plus b minus c also divisible by 4, and this is nothing but a minus c is divisible by 4. Since after adding we get a minus c, b cancel, a minus c is divisible by 4, and this is nothing but magnitude of a minus c is divisible by 4, and hence a order pair AC belongs to R. This imply a comma b belongs to R and b comma c belongs to R. Finally we get a comma c belongs to R, a comma b belongs to R and b comma c belongs to R. Therefore a directly related to c belongs to R. Hence we conclude that this relation is symmetric, transitive. This is the condition for transitivity. Hence it is transitive. Next I would like to discuss one thing more for your development, your concept, that is point to be noted, identity relation. As I have already discussed in my previous video lecture, suppose identity relation on a set A, and suppose set A is 1 2 3 4, and therefore identity relation defined as 1 1 2 2 3 3 4 4 5 4 4, last number 4 4. Here this is identity relation. Point to be noted here, identity relation itself symmetric. Identity relation itself symmetry. Since we know that for symmetry a comma b belongs to R, this implies b comma a belongs to R. Here 1 1 belongs to R. After change of order we get also 1 1 belongs to R. This is the condition for symmetry. Hence we conclude that every identity relation itself a symmetry relation. Next, let us start equivalence class. What do you mean by equivalence class? First of all, I define equivalence class. Equivalence class. Let R be an equivalence relation in a set A, and let P be any elements belongs to set A, then the set of all those elements of A which are related to P belongs to A, to P is called equivalence class, and it is denoted by a square bracket P. Thus, from definition we can write it as follows: equivalence class P is equal to nothing but a set Q belongs to A such that P comma Q belongs to R. This is the equivalence class. Equivalence class of every element of set A. First of all, we have to find, and we construct example with. Now we construct example as follows: A set A whose elements are 1, 2, 3, 4, 5, and we establish a relation here: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 1, 2, 2, 1, 2, 3, 3, 2, 1, 3, 3, 1. This is the relation. First of all, before discussing equivalence class, we have to check the relation R is equivalence or not. If R is equivalence relation, then after we find equivalence class of each element of set A, otherwise not possible. First of all, the relation must be equivalence relation. Then after we calculate equivalence class of elements 1, 2, 3 and 4 of set A. First of all, we check this relation, either reflexive or symmetry or transitive. For reflexive, we see that here 1 is also related to 1, 1, 2, 2 also related to 2, 3, 3 also related to 3, 4 also related to 4, 5 also related to 5. This is the reflexivity, condition for reflexivity, and this relation is reflexive, clear. Symmetricity, we choose 1, 2, there are then 2, 1 must be belongs to set R, relation R. 1, 2 belongs to R here, and 2, 1 also belongs to R. 2, 3 belongs to R, and 3, 2 also belongs to R. 1, 3 belongs to R, 3, 1 also belongs to R. Therefore, this is the symmetry. Now for transitivity, suppose we choose 1, 2. 1, 2 belongs to R, and 2, 3 belongs to R. Therefore 1, 2, 2, 3. Therefore 1, 3 must belongs to R. Must belong 1, 3. 1, 3 also belongs to R. Therefore this is the condition: A, B, B, C. Therefore AC. This is the condition for transitive, and this is also transitive. Then we have to discuss equivalence class. What is the meaning of equivalence class of elements 1, 2, 3, 4, 5? Now equivalence class of equivalence class of each element of set A. Therefore equivalence class of element 1, that means equivalence class of 1 means 1 related to which? 1 related to 1 means 2, 1 related to 1, set 1 is 1, and also 1 related to 2 is also here, and 2 and 1 also related to 3, the 3 here, and 1 also 1 related to 1 related to 2, and 2 related to 1, same thing. 1 related to 3, yes, 3 related to 1, both are same, and hence the equivalence class of 1 is the set of elements, the elements 1 related to set A, 1 related to 1 related to 2, 1 related to 3. Therefore this is the equivalence class of elements 1. Similarly, equivalence class of 2 means 2 related to which? 2 related to 2. So first of all 2 related to 2 related to, and therefore 2 related to 2 is the element, and 2 related to 1 also, 2 related to 1, 2 related to 2, and 2 related to 1, 1 related to 2, yeah, 2 related to 1, same thing, and 2 related also 3, and therefore also 3 2. This is the equivalence class of 2. मतलब ये होता है इक्विवेलेंस क्लास का मतलब कि ये जो 2 का इक्विवेलेंस क्लास हम बना रहे हैं, इसको ये देखना है कि ये रिलेशन में 2 किससे रिलेटेड है. तो यहाँ पर 2 जो है 2 से रिलेटेड है, तो एक 2 एलिमेंट हो गया. 2 और आपका 1 से 1 से रिलेटेड है, तो 1 भी एक एलिमेंट हो गया. 2 का रिलेशन 1 से हो गया. फिर 2 का रिलेशन 3 से भी हो रहा है. 2 का रिलेशन 3 से है. 2 रिलेटेड 3 या 3 रिलेटेड 2, दैट इज सेम थिंग. 2 रिलेटेड टू 3 है. 3 द ऑल्सो 2 का एक इक्विवेलेंस क्लास बना इसका. तो दिस इज द इक्विवेलेंस क्लास, बोथ आर सेम, इसलिए पार्टीशन इसको कहते हैं, पार्टीशन P1 एंड P2. दिस इज द पार्टीशन P1 एंड P2. P1 and P2 is the first partition and second partition, but here both are same, 2 1 3. That means to say this is nothing but 1 2 3, both are same. This is the one partition, this is the one partition, both are same, this is the one partition. And next with 3 इक्विवेलेंस क्लास ऑफ 3 के बारे में हम लोग बात करते हैं. तो 3 से देखना है कि 3 किस एलिमेंट से रिलेटेड है. तो 3 पहला तो 3 हो जाएगा, 3 से है तो 3 हो जाएगा. इसके बाद 3 2 से भी है, 2 हो जाएगा. इसके बाद 3 2 से हो गया, 3 1 से भी हो गया. तो दिस इज ऑल्सो सेम थिंग, 1 2 3. दिस इज ऑल्सो P1, पार्टीशन 1 ही है ये भी, जो कि डिफरेंट नहीं है इस सबसे, इसलिए ये पार्टीशन 1 ही इसको बोलेंगे. 4 का देख लेंगे, 4 का इक्विवेलेंस क्लास निकाल लेंगे. तो 4 किस एलिमेंट से इसमें रिलेटेड है. तो 4 से है तो 4 ही हो जाएगा, पहला नंबर तो 4 ही हो जाएगा. 4 के साथ और किसी का रिलेशन नहीं है. दिस इज द एंड दिस इज द अनदर, दिस इज द P2, दिस इज द फाइनली P2. एंड तीनों जो है ये P1 ही कहलाएगा. ये P1 पार्टीशन ऑफ सेट, पार्टीशन कहते हैं इसको, पार्टीशन P1 P2. तो 2 पार्टीशंस, नंबर ऑफ पार्टीशंस इज इक्वल टू 2. एंड 5 का तो आपके पास यहाँ पर कुछ भी एलिमेंट, 5 का एक ही एलिमेंट है, इसका भी 5 का भी एक ही एलिमेंट है 5. हाँ यस, यहाँ पर भी एक P3 बन गया, ये अलग चीज़ हो गया P3. तो यहाँ पर 3 पार्टीशंस हो गया आपका, 3 पार्टीशन, नंबर ऑफ पार्टीशंस मैंने कितने आपके सेट बनते हैं डिफरेंट, दैट मीन्स पार्टीशन, डिफरेंट पार्टीशंस P1 P2 P3. बट हियर ऑल आर ये सेम थिंग. P1 ही पार्टीशन, ये P2 पार्टीशन, P3 पार्टीशन, ऑल आर. तो इक्विवेलेंस क्लास का मतलब ये होता है कि वो एक सेट ही होता है कि जिस एलिमेंट का इक्विवेलेंस क्लास हम निकालते हैं उसको ये देखना होता है कि रिलेशन में वह एलिमेंट किस से रिलेटेड है. तो 1 का रिलेशन किसके साथ है, 1 रिलेटेड टू 1, ठीक है 1 हो गया. 1 रिलेटेड टू 2 भी हो गया इसका. 1 रिलेटेड टू 3 भी हो गया. इसके अलावा कुछ नहीं है, बस हो गया. फिर 2 का देख लेंगे. इसी तरह से पार्टीशन इसको कहते हैं P1 P2 P3 सेट हुआ, पार्टीशन 1 पार्टीशन 2 पार्टीशन 3, तो देयरफॉर 3 पार्टीशंस पूछता है क्वेश्चंस में कि हाउ मेनी नंबर ऑफ पार्टीशंस ऑफ द यूजर। तो सबसे पहले इक्विवेलेंस क्लास बनाने से पहले रिलेशन को देखना होता है कि वह इक्विवेलेंस रिलेशन है कि नहीं, तभी हो सकता है उसका इक्विवेलेंस क्लास, अदरवाइज नॉट पॉसिबल। नेक्स्ट वीडियो में हम लोग बात करेंगे नंबर ऑफ रिलेशंस ऑन ए सेट, कितने रिलेशंस, मैक्सिमम रिलेशन किस सेट पर हम लोग बना सकते हैं, नंबर ऑफ रिलेशन, हाउ टू कैलकुलेट, एक फार्मूला हम लोग उसको एस्टेब्लिश करेंगे। इसके बाद हम लोग देखेंगे कितने सिमेट्रिक रिलेशन उस पर हम डिफाइन कर सकते हैं किसी सेट पर। इसके बाद हम लोग ये देखेंगे कि कितने रिफ्लेक्सिव रिलेशन एस्टेब्लिश कर सकते हैं। ये सारी चीज़ हम लोग अगले वीडियो क्लास में हम लोग देखेंगे, इसके बारे में हम लोग